In this chapter, we learn about the ideal gas law and the kinetic theory of gases. We start with a discussion about molecular mass, the mole, and Avogadro's number. Often, we wish to compare the mass of one atom to another. To facilitate the comparison, a mass scale known as the atomic mass scale has been established. To set up this scale, a reference value, along with a unit, is chosen for one of the elements. The unit is called the atomic mass unit. By international agreement, the reference element is chosen to be the most abundant type or isotope of carbon, which is called carbon-12. Its atomic mass is defined to be exactly 12 atomic mass units, or 12U. The relationship between the atomic mass unit and the kilogram is 1U equals 1.6605 times 10 to the minus 27 kilograms. The atomic masses of all the elements are listed in the periodic table, part of which is shown here. In general, the masses listed are average values and take into account the various isotopes of an element that exist naturally. The integer number is the atomic number, which gives the number of protons in the nucleus of the atom. The lower number is the atomic mass. For brevity, the unit U is often omitted from the table. As an example, let's use the periodic table to compare the atomic masses of two different atoms. A magnesium atom has an average atomic mass of 24.305 U, whereas a lithium atom has an average atomic mass of 6.941 atomic units. Thus, a magnesium atom is 24.305 divided by 6.941, which equals 3.502 times more massive than a lithium atom. In the periodic table, the atomic mass of carbon is given as 12.011 atomic units rather than exactly 12U. This is because a small amount, about 1%, of the naturally occurring material is an isotope called carbon-13. The value of 12.011 atomic units is an average that reflects the small contribution of carbon-13. The molecular mass of a molecule is the sum of the atomic masses of its constituent atoms. For instance, the elements hydrogen and oxygen have atomic masses of 1.00794 atomic units and 15.9994 atomic units respectively, so the molecular mass of a water molecule, H2O, is therefore 2 times 1.00794 atomic units plus 15.9994 atomic units, which is equal to 18.0153 atomic units. Macroscopic amounts of materials contain large numbers of atoms or molecules. Even in a small volume of gas, 1 centimeter cubed for example, the number is enormous. It is convenient to express such large numbers in terms of a single unit, the gram mole, or simply the mole. 1 gram mole of a substance contains as many particles, atoms or molecules, as there are atoms in 12 grams of the isotope carbon-12. Experiment shows that 12 grams of carbon-12 contain 6.022 times 10 to the 23rd atoms. The number of atoms per mole is known as Avogadro's number, Na, after the Italian scientist Amedeo Avogadro. And that number is 6.022 times 10 to the 23rd atoms per mole. The concept of mole can be applied to any particle, including atoms, molecules, or even golf balls. To give you some intuition about the magnitude of Avogadro's number, a mole of golf balls would cover the entire surface of the Earth with a kilometer-thick layer of golf balls. Given the number of particles n of a substance, the number of moles, n, is given by n equals n divided by Na. The number of moles can also be found from the mass of the substance by multiplying the numerator and denominator in this equation by the mass of the particle. The numerator is then equal to the mass of the substance, and the denominator is the mass per mole expressed in grams. The mass per mole, in grams per mole, of any substance has the same numerical value as the atomic or molecular mass of the substance in atomic mass units. Therefore, 1 mole of hydrogen has a mass of 1.00794 grams, beryllium has 9.01218 grams per mole, and a mole of magnesium has a mass of 24.305 grams. As a side note, In chemistry, the atomic mass is often referred to as atomic weight. Although not technically correct, the terms are used interchangeably. In summary, the relationship between the atomic mass unit and the kilogram is 1 atomic mass unit equals 1.6605 times 10 to the negative 27 kilograms. 1 gram mole, or mole, of a substance contains as many particles as there are atoms in 12 grams of carbon-12. This number is Avogadro's number and is equal to 6.022 times 10 to the 23rd atoms per mole. Finally, the number of moles in a given substance can be determined from the total number of particles of the substance by dividing by Avogadro's number, Na, or from the mass of the substance by dividing by the mass per mole of the material.